Okay, ladies. Today what we're going to do is so yesterday we were talking about concentrations. So we looked at different examples of concentrations. Today we're going to focus on the last one, which is molarity. Okay? Number of moles per liter. So I'm just going to go over a few questions with you. This? So let's look at some examples of questions, okay? So some really easy concentration questions. So for example here, a solution of cupric sulfate, so CuSO4, is used at blood donor clinics to test donor blood flow for low iron. Calculate the concentration in the solution in molarity, moles per liter, if 125 grams of copper sulfate are dissolved in 1 liter of water. So let's start with a really basic, really simple question, right? So concentration, we saw there's different ways you can do concentration. So we're going to talk about concentration in molarity. Now, I think yesterday I wrote this formula. So it's you can actually write it as, I believe your textbook uses C instead of big M. So it's C equals N over V. But the unit for concentration is molarity, okay? So it's the big M. So first thing you do is you figure out how many moles you have. So how many moles you have, that's easy, right? We have the formula for that. Mass over molar mass. We have 125 grams of copper sulfate. Now, what's the molar mass of copper sulfate? Someone just look it up. Because, you know, I think we're past that point now where we can figure out molar mass. So what's the molar mass of copper sulfate? Just Google it. What does it come out as? Sorry? Yeah?
159.6.
Okay, we'll just say 160. 160 grams per mole. Okay, so how many moles does that represent? Hold on. All right, so that was a bit of an interruption there. Okay, so what was I saying? How many moles is that? 0.78. Okay, good. So 0.78 moles. Okay, now concentration is number of moles over the volume. The volume has to be in liters. So the concentration is number of moles over the volume. So it's 0.78 moles over 1.0 liters. So the concentration is 0.78 big M. Or moles per liter. If you want to write moles per liter, that's fine. Wow, what a hard question. See? Nora? What do you think? Hard? Don't you wish all the questions were as difficult as this? Okay. So I'll give you a bit of time to copy this down? Alright. So let's pause it. Alright, so ladies, let's look at the next question, okay? Next question is, we want to know the mass of potassium permanganate. That would be in 750 milliliters of a solution that has a particular concentration of 0.48 moles per liter. So if you think about what we have in this question, right? The formula that we just looked at was C equals N over V, right? Okay. Now, we're given two things. We're given the volume and we're given the concentration, correct? Now, if you want to know the mass of something, you could do, or you could use this equation, right? Because if you know the number of moles, if you know this, and you can determine the molar mass, you can isolate for the mass. So then we could rearrange and say, well, for this one, mass is equal to number of moles times the molar mass. So what do you think we should do in this question then? Okay, let's start with that. Let's find the number of moles. So let's start with, what is N? Okay. Right, so N equals C times B. Alright, so concentration is 0.480 moles per liter. The volume is 7, but no, the volume has to be in what though? Liters? Okay, so the volume is going to be 0.750 liters. So that gives us the number of moles. So how many moles would that be? Well, that should be 0.36. 0.360 moles. Now we have little n. So then, if we consider this to be step 1, then in step 2, we can solve for the mass. So the mass is going to be the number of moles times the molar mass. The number of moles is 0.360 moles. The molar mass is 158 grams per mole for potassium permanganate. 50. So we'll say 57. About 57 grams. Okay? I'll pause it there. Okay, so next question. Alright, so we have a solution of a sodium oxalate. And it says that we dissolve 8.5 grams in 500 milliliters of distilled water. And then we want to know the concentration of sodium and oxalate ions. So in this formula of sodium oxalate, obviously we know what the sodium is. So the sodium would be this part. That means that this would be the oxalate. So what would oxalate be then? It should be C2O4 minus 2. Because if you remember from the crossover rule, sodium is plus 1. So sodium is Na plus. So remember, this is an ion compound. So in water, what's it going to do? It's going to split up into its ions, right? So when it splits, how many sodium ions will you get? Well, the formula says that we have 2, so you should get 2 sodium ions and 1 oxalate ion. For every 1 molecule of the sodium oxalate, it should split into 3 ions, basically. 2 sodium and 1 oxalate ion. But let's start with the really basic question. What's just the concentration of the sodium oxalate? Okay, so let's start with that. So form concentration is what? C equals N over V. Okay, so but we don't have the mass. We don't have the number of moles, right? So we gotta solve for the number of moles. So the number of moles is mass over molar mass. So we have 8.5 grams given in the question. The molar mass of sodium oxalate was 134. Okay. So how many moles is that? 0.06? Okay. 0.06 moles. Now we have the number of moles. So now we can go back to equation for concentration. Number of moles is 0.06. The volume is 500 milliliters, but Megan, it's got to be in what? Liters, huh? So 500 milliliters is 0.5 liters. So what's our concentration? That should be 0.12 m. Now, question they'll ask you for the concentration of the sodium ions and the oxalate ions. So if you look at the sodium ions, understand that the sodium oxalate will split into 2 sodium ions. So then the concentration for the sodium ion should be times 2, which makes it a concentration of 0.24 moles. The oxalate, which is C2O4 -2, splits, and you only get 1 ion, so it's the same as the concentration of the sodium oxalate, which is 0.12. Okay, so in questions like this, where you're trying to figure out the concentration of the ions, start with the concentration of the actual compound. Then once you know the concentration of the compound, if you get 2 ions for every compound, multiply by 2. If you get 3 ions, multiply by 3. If you get 4, you multiply by 4. Okay? Okay, last question. So what I'll do is I'll pause it so you can write down the question, then we'll take it up, okay? So I'll pause it. Alright. Okay, last question, ladies. Alright. D5W, not to be confused with WD-40, which is used to, if you have like squeaky metal and stuff like that, like hinges, and you can use that to lubricate the surfaces. D5W is used in the hospitals, supposedly. I don't know, I've never really checked. And it contains glucose. So you can see that you're the pharmacist, you want to make a 750 milliliter solution. Concentration you want is 0.30 moles per liter. What mass would you need to dissolve in water? So again, the formula for concentration is C equals N over V. So start with the number of moles. So let's start with that. Because if we want mass, we need to know the number of moles, right? So the number of moles is 0.30 moles per liter. That's your concentration. That's your C. And the volume is 0.750 liters. Okay? So the answer, thanks Giselle for saying it 15 times, is 0.225 moles. Okay? And then once you have the number of moles, you can figure out the mass, because mass is number of moles times molar mass. So the mass is the number of moles. And glucose, the molar mass of glucose is 180. So the mass that you would need is 40 point, hold on, pen froze. 40.5 grams. And that, my friends, is it.
Okay, that's nice.